you for the opportunity provided. My name is Bini Msesha, and in this collaborative research, a gravity dam's structure response to an earthquake event was modeled. So dams are essential structures for navigation, hydroelectricity, and flood mitigation, but pose a significant threat to downstream communities in the event of an earthquake. Earthquake increases the hydrodynamic pressure and inertial forces acting against the stability of dams. Henceforth, predicting expected deformation and stresses on the dam body to a probable earthquake event is often an integral part of the dam design. But depending on the analysis type chosen, predicted deformation and stresses may vary. So in this regard, choosing a method representative of the actual system is important. So in this investigation, resulted obtained by 3 techniques was compared. The first one was a static model. The second and the third being one-way and two-way FSI models. So in response of a dam to forces of uplift, weight of dam, and hydrostatic pressure can be easily computed using a static model. However, when earthquake-induced hydrodynamic stresses and inertial forces are present, the use of FSI simulations helps gain accurate understanding of the system. In one-way FSI models, only the fluid pressure acting on the structure-fluid interface is transferred to the structure solver, whereas in two-way coupled simulation, the displacement of the structure is additionally transferred to the fluid solver, which is expected to increase the accuracy. So with this in mind, the study area was located in Ethiopia. It's Gilgel gibe 3 dam. It's made of reinforced concrete. And so the particular study area where the dam is located is known to have a 20% risk for 7 to 8 Richter scales earthquake, which probably which will occur within the the service period of the dam. So in terms of the model, ANSYS fluent and ANSYS mechanical were used. So the computational domain is presented in figure 1. There you see the red one is for the structural analysis, and during the static analysis, that was the only mesh used, not the fluid part. But for the coupled simulations, both meshes were used. So that the boundary conditions does not influence the results on the dam. So the downstream and upstream boundaries were stretched further from the dam body, as you see, 750 meters downstream and 300 meters upstream. And with respect to grid cells for the dam geometry, about 2 meters were the elements used. In terms of the fluid domain, 1 up to 5 was used, where 1 was close to the dam, and somehow to the downstream section where we expected to have a flow on the spillway, because this also is a 2-phase simulation. So the water level up to the reservoir, to the maximum reservoir water level was water, but above that was air. So the refinement you see below the dam is so as to capture, let's say, the turbulence when the flow dissipates over the spillway, but we didn't see that, not that much important. So in terms of the result, so the results are presented in figure 2. The first one presents the total deformation with the time, and the 3 are presented here. Okay, so in terms of panel A, so the maximum deformation in the dam body predicted by the 2-way coupled FSI model linearly increased with time, while that predicted by the other models were smaller. And this linear relationship was actually started around 2, which is the time where we have the maximum ground acceleration. So it could be related with this. In terms of the panel B, what is visualized there is the minimum principal stress. So more or less here, we tried to see the tensile stress, for which RCC dams are not good because they're made of roller compacted concrete, and its tensile strength is not that much. So we tried to see this as well. And also there are other results which are not presented here, but generally we observed that the the stresses are within the allowable limits. Okay, with that, I conclude my findings. So stress predicted by the different models shown different stress time relationships. The stress predicted by the different models were within the safe limits of the dam. The high deformation predicted by the two-way couple FSI model was attributed to its accuracy, but we recommend further investigation on the matter. Okay, so with this, I thank you.